In the heart of Central Africa, on the border of modern-day Congo and Uganda, archaeologists uncovered a tool carved from bone. It's only 10 centimeters long. And it was made nearly 20,000 years ago. At first glance, it looks simple, almost ordinary, but on its surface are patterns deliberate, structured, and intentional. And those patterns completely challenge the accepted timeline of human knowledge. This is the Ishango Bone, and it may represent one of the earliest records of mathematical thought in human history. In the 1950s, Belgian archaeologist Jean de Heinzelen made a remarkable find near the shores of Lake Edward. The Ishango Bone was resting in a grave, nestled alongside stone tools from the Late Stone Age. The estimated date, somewhere between 18,000 and 20,000 years before the present. As Heinzelen examined it, he noticed groups of lines etched into its surface. These weren't random scratches from use. They were markings arranged in distinct columns. He saw what looked like numerical sequences. He found patterns of doubling, and even hints of a base 10 counting system. The markings appeared to be deliberate. One column, for example, contained groups of notches that corresponded to prime numbers. The implications were staggering. Could this be more than just a simple tally stick? So, what do these markings actually mean? The bone has 3 columns of notches. One column contains the groups 3 and 6, then 4 and 8. Then 10 and 5, followed by 5 and 7. Notice the doubling pattern. 3 doubled is 6. 4 doubled is 8. 10 is double 5. The presence of these patterns suggests a level of abstract thought. Another column is even more fascinating. It contains the numbers 11, 13, 17, and 19. These are all the prime numbers between 10 and 20. The deliberate use of primes, doubling, and structured sequences suggests something far more complex than simple counting. It implies organized thought, pattern recognition, and a sophisticated understanding of numbers. Some researchers believe the bone may be a lunar calendar, perhaps used for tracking menstrual cycles or the phases of the moon across several months. Others argue it's proof of early arithmetic, a tool for addition, multiplication, maybe even division. The debate continues, and there's no universal agreement among historians and mathematicians. But the evidence overwhelmingly leans toward one incredible fact: whoever made this bone understood numeric relationships in a way that predates most known mathematical systems by thousands of years. Traditional history often credits the birth of mathematics to ancient Mesopotamia and classical Greece. But the Ishango Bone predates both of these civilizations by tens of thousands of years. This forces us to ask a profound question: was Africa developing complex mathematical thought long before the so-called cradles of civilization even existed? The bone suggests that ancient African communities were not just surviving during the Late Stone Age, they were observing, calculating, recording, and maybe even predicting. There is undeniable structure here: logic, intentionality, and a clear grasp of abstract concepts. This single artifact has the power to rewrite the early chapters of human intellectual history. Of course, we have to acknowledge the limits of our knowledge. The bone is, by its very nature, ambiguous. We cannot speak for its maker. We can't know their exact intentions. We certainly cannot claim it represents advanced algebra or geometry. And there is no proven direct continuity from the Ishango Bone to later mathematical traditions in Egypt or elsewhere. It could just be a coincidence, or a tool with a purpose we can't yet imagine. But dismissing it entirely, just because it doesn't fit neatly into our familiar historical narratives, is not intellectually honest. The patterns are too specific, too structured to be easily ignored. The Ishango Bone is not an isolated anomaly. Across Africa, evidence of early science and sophisticated knowledge appears again and again, if you know where to look. We have the Nabta Playa astronomical site in Nubia, which predates Stonehenge. We have the incredible architectural engineering of ancient Ethiopia. We have the complex metallurgy of West Africa. These discoveries paint a picture of a continent rich with innovation and intellectual curiosity, long before the history books usually start paying attention. The question is not whether Africa contributed to the grand story of human knowledge. The real question is why these contributions are so consistently minimized, overlooked, or ignored. Ultimately, this Shango bone will not definitively solve the mystery of the origins of mathematics, but it does something far more important. It challenges the lazy assumption that knowledge evolved in a straight, linear path through a single region of the world. It reminds us that human ingenuity is universal and has flourished in many places, at many times. Somewhere, 20,000 years ago, a human being in Central Africa carved numbers into a piece of bone. We don't know their name. We don't know their language. But we know this: they were thinking, they were measuring, they were asking questions. And that, right there, might just be the true beginning of mathematics. So, what do you think this Shango bone represents? A simple tool, a feat of observation, the dawn of science, or early mathematics? Leave your view in the comments below. And if you want more history without the usual shortcuts, make sure to subscribe. Thanks for watching.